For decades, Americans have used water as though their supply would never run out. In recent years, drought conditions have forcibly brought the need to conserve and properly budget our water resources to the minds of water supply managers. Even in the driest years, though rain across the country enormously exceeds water use, the trouble is the nation's water resources are unevenly distributed. The Pacific Northwest has a big surplus. The agricultural states of the Southwest fight for the last salty drop of river water from the lower Colorado River. The federal government has spent billions of dollars building and operating facilities to divert water for use in arid areas and those without ready access to water. Contamination is a problem too. Mineral residues from irrigation have damaged once fertile soil. Acid rain is killing the fish in mountain lakes. Americans' drinking water has been tainted with substances as unfamiliar as trichloroethylene, TCE, and as commonplace as highway salt. Vast underground basins of water deposited over many years have been seriously depleted in a matter of decades. All water comes as rain or precipitation from the sky, but 92% of the water either evaporates immediately or runs off eventually into the ocean. 1/4 of the water that irrigates, powers, and bathes America is taken from an ancient network of underground aquifers. According to U.S. geological surveys, in 1950, the United States took some 12 trillion gallons, 45 billion cubic meters of water out of the ground. By 1980, the figure had more than doubled to 30.7 trillion gallons. In 2010, last year for which data is available, the rate has dropped to 28.8 trillion gallons. This decrease can be attributed to technological innovations that allow more efficient use of water and to conservation efforts in response to water shortages caused by droughts and other climate factors. Water shortages directly influence energy consumption. As groundwater levels fall, more energy is required to pump water from deeper levels in the basin. In several areas, vast water projects use large amounts of electricity to pump water many miles along the project. As energy becomes more expensive, the users of the water will see the increased cost reflected in their water rates. This link between water demands and pumping costs drives water conservation programs, even where water is abundant. Water is regarded as commonplace because it is the most plentiful liquid on Earth and because of our familiarity with it. Water is present in almost all natural objects and in almost every part of the Earth that people can reach. There is water vapor in the air and liquid water in rocks and soil. In addition to the water that wets them, clay and certain kinds of rocks contain water in chemical combination with other substances. Both plant life and animal life depend upon water for survival. A plant receives the greater part of its food from the soil in water solutions and manufactures the rest of its food in the presence of water. Like other animals, all of the tissue of human bodies are bathed in water. Our food must be suspended and dissolved in water solutions to be carried to the different parts of the body. Also, most waste products are eliminated from the body as water-soluble substances. Water may be commonplace, but useful water is not always readily available. Even before the discovery of America, one of the common causes of war between Native American tribes was water rights. Among the first consideration of any new land development is water. Useful water is only rarely free, and it is not very abundant in many parts of the United States. There are not many places left where a person can feel safe in drinking water from a spring, stream, or pond. Even the groundwater produced by wells must be tested regularly. In some areas, human activities have made it difficult to locate safe water supply of any sort. In certain coastal areas, for example, overpumping from the ground has depleted the groundwater basins. As a result, the intrusion of seawater is ruining the basin for most useful purposes. Other sources of groundwater contamination include seepage from septic tank leaching systems and agricultural drainage systems, the improper disposal of hazardous waste in sanitary landfills and dumps, and the entry of surface runoff into poorly constructed wells. Some human activities clearly pose a serious threat to life on this planet. Check your understanding. Question number 1. Why has it become necessary to conserve and properly budget our water resources? Question number 2. How are water shortages and energy consumption linked together? Question number 3. Why do many sources of water need treatment? Question number 4. Name 3 ways groundwater may become contaminated. Here ends Section 1. Section 1.2, Water Treatment. The basic objective in the operation of water treatment plants is to produce a drinking water that is safe and aesthetically pleasing at a reasonable cost with respect to capital as well as operation and maintenance. From a public health perspective, production of a safe drinking water One that is free of harmful bacteria and toxic materials is the first priority. It is also important to produce high-quality water that appeals to the consumer. Generally, this means that the water must be clear, free of turbidity, colorless, and free of objectionable tastes and odors. Consumers also show a preference for water supplies that do not stain plumbing fixtures and clothes, do not corrode plumbing fixtures or piping, and do not leave scale deposits or spot glassware. Consumer sensitivity to the environment, air quality, water quality, noise, has significantly increased in recent years. With regard to water quality, consumer demands have never been greater. In some instances, consumers have substituted bottled water to meet specific needs, namely for drinking water and cooking purposes. Design engineers select water treatment processes on the basis of the type of water source water quality, and desired finished water quality established by drinking water regulations and consumer desires. Table 1.1 is a summary of typical water treatment processes as they relate to the source and quality of the raw water. Raw water means water in its natural state before any treatment, or water entering the first treatment process of a water treatment plant. Water has many important uses, and each requires a specific level of water quality. The major concern of the operators of water treatment plants and water distribution systems is to produce and deliver to consumers water that is safe and pleasant to drink. The water should be acceptable to domestic and commercial water users and many industries. Some industries, such as food and drug processors and the electronics industry, require higher quality water. Many industries will locate where the local water supply meets their specific needs, while other industries have their own water treatment facilities to produce water suitable for their needs. Check your understanding. What is the first priority for operating a water treatment plant? Number 2, what type of water is appealing to consumers? And number 3, which industries require extremely high quality water?